Chemical properties of carbon compounds. We have millions of carbon compounds. The reactions they undergo are limited. Some of the important reactions among them are combustion reactions, oxidation reactions, addition reactions, and substitution reactions. Combustion reactions. The process of burning of carbon or carbon compound in excess of oxygen to give heat and light is called combustion reaction. Example 1. Saturated hydrocarbon like ethane burns with clear blue flame because the number of oxygen atoms are sufficient to break carbon-carbon bonds. Here, ethane reacts with oxygen to form carbon dioxide, water vapor and liberates heat energy. 2C2H6 plus 7O2 gives rise to 4CO2 plus 6H2O plus energy. 2. Unsaturated hydrocarbon like ethyne burns with yellow sooty flame because the number of oxygen atoms are insufficient to break carbon-carbon bonds. Here, ethyne reacts with oxygen to form carbon dioxide, water and liberates heat energy. 2C2H2 plus 5O2 gives rise to 4CO2 plus 2H2O. Example 2. If air is not sufficiently available during combustion, even saturated hydrocarbons give sooty flame. The cooking vessels get blackened on a gas stove because of the inlets of air getting closed. The fuel gases do not completely undergo combustion. Example 3. When coal is burned, they just glow red without flame. This is because to get a flame, gaseous fuel should burn. Oxidation reactions. Primary alcohols can be oxidized to form aldehydes and carboxylic acids. These reactions occur in the presence of catalysts like alkaline potassium permanganate or acidified potassium dichromate. Take 5 ml of ethanol by dropper and drop it into the test tube. Add 5 ml of alkaline KMnO4 into the test tube. It will turn into purple color. After a few minutes, the solution becomes colorless. Now, take blue litmus paper and dip it into the test tube. The blue litmus paper turns into red color. This shows that ethanol is converted into ethanoic acid. Alkaline potassium permanganate or acidified potassium dichromate in solutions act as oxidizing agents and supplies oxygen to convert alcohols into carboxylic acids. Ethyl alcohol undoes oxidation in 2 steps. In step 1, alcohol CH3CH2OH is oxidized from ethanol CH3CHO in the presence of catalysts like alkaline potassium permanganate or acidified potassium dichromate. In step 2, it forms ethanoic acid CH3COOH. Addition reactions. The hydrocarbons that contain at least one double bond or one triple bond between 2 carbon atoms are called unsaturated hydrocarbons. Alkenes and alkynes are the examples of unsaturated hydrocarbons. Unsaturated organic compound like 2-butane reacts with hydrogen in the presence of nickel catalysts to form 2-butene, that is, unsaturated organic compound. Again, 2-butene reacts with hydrogen in the presence of nickel catalyst and forms butane saturated hydrocarbon. Substitution reactions. A reaction in which an atom or a group of atoms in a given compound is replaced by another atom or group of atoms is called a substitution reaction. Alkanes, the saturated hydrocarbons, are chemically least reactive. Therefore, they are also called paraffins, that is, no affinity towards chemical changes. For example, methane CH4 reacts with chlorine molecule in the presence of sunlight to form methyl chloride and hydrogen chloride. Here, hydrogen atoms of methane are replaced by chlorine atoms. Methyl chloride reacts with chlorine molecule to form dichloromethane and hydrogen chloride. Here, hydrogen atoms of methyl chloride are replaced by chlorine atom. Dichloromethane reacts with chlorine molecule to form trichloromethane and hydrogen chloride. Here, hydrogen atoms of dichloromethane are replaced by chlorine atom. Trichloromethane reacts with chlorine molecule to form carbon tetrachloride and hydrogen chloride. Here, hydrogen atoms of trichloromethane are replaced by chlorine atom.